Welcome back to the video series on integration and differential equations. In today's video, we're going to talk about the product rule for differentials. So let's start with the following example. Let's say we want to take the differential of the following product, e to the 4x times y. So we're going to apply a rule here that looks similar to the product rule for derivatives. The only difference is instead of calculating derivatives, we're going to calculate differentials. So here's how it would work. We'd take our first factor, e to the 4x, write that down. Then we multiply that by the differential of the second factor. So the differential of y is just what we call dy. And then we're going to go plus, and we're going to do this the other way around. So this time we're going to take our second factor, y. We're going to multiply that by the differential of the first factor. So the differential of e to the 4x would be e to the 4x times 4. That's our derivative. And to turn that into a differential, multiply by dx. So what we'd likely do in the next step is just clean this up a little bit. Our final answer would look like e to the 4x dy plus, we'd normally write any x expressions before the y, so we'd normally write 4 e to the 4x y dx. Okay, so that's our product rule for differentials, and we've done a little bit of simplification as well. Now let's try to reverse this process. In this example, we're going to write the expression as a differential, and what we've got here is a sum of two terms. We want to write it as a single differential. So notice that this is the exact same expression as we had up above here. So these two expressions are equal. So in fact, we already know the answer. The answer should be the differential of e to the 4x times y. And let's see if we can come up with a shortcut for how to move from this step to this step. So let's see what our shortcut should be. Here's how our shortcut's going to work. We're going to locate the dy term. We're going to replace the dy with y. And that new expression will go inside the differential. And we'll check our work just to make sure using the product rule. So let's try it. Here's our dy term. Replace the dy with a y, so we'd get e to the 4x times y. That expression goes inside the differential. So at this point we believe this is the correct answer. The way we would check it, apply the product rule to this. So we're basically going from this step back to this step and just confirming that it's true. So applying the product rule, we'd have e to the 4x dy plus y times 4 e to the 4x dx. So yes, that does give us the correct answer. All right, so let's try it for a couple more expressions. Part B, let's see if we can write this expression here with two terms as a single differential. So we locate the dy term, we replace dy with y, that would give us e to the negative 2xy, and we put that expression inside a differential. So we believe this is the correct answer, but to confirm, let's apply the product rule. We'll work backwards and make sure that we really do get our original expression. So applying the product rule, we'd have e to the negative 2x dy. That's good. That gives us our first term. And then we go plus y times negative 2 e to the negative 2x dx. So yes, that does give us the correct second term here, and we can confirm that our shortcut has worked. Third and final example here, let's start with the expression x cubed dy plus 3x squared y dx, and let's try to write that as a single differential. So we'd locate our dy term, we'd replace the dy with a y, and we put that inside a differential. So to confirm that this is correct, we'd apply the product rule to this, make sure that we get our original expression. Applying the product rule, we'd have x cubed dy plus y times 3x squared dx. So yes, that does give us the original expression back, and we know for sure that we've done that correctly. In our next video, we're going to see a second method for solving DEs, and we're going to find this discussion here about the product rule for differentials very helpful when we're seeing that new method. Thanks for watching, and we'll see you in the next video.